Welcome and thank you for joining. As part of preparation for the Advanced Functions final exam, this year you were given an in-class mock examination. The purpose of writing a mock examination is for you to experience writing an exam in class. It's been 3 years since you've written the last exam in high school. That must have been grade 9. And also, try to explore more the time management skills you have and the ones that you need to acquire. And most importantly, we want to review or get a sense of what we know best or what we remember best from the entire course and what we need to work on. So for the rest of the exam preparation period, then we can focus on practicing those skills a little bit more. In order to help you correct or mark your own mock examination and understand the mistakes, I decided to take up the questions and record them. So the mock examination, just like the final exam, is made up of two parts. Part A is in the form of multiple choice questions, and Part B is in the form of full or complete solutions. So we're going to get started with Part A, question 1. When x cubed plus kx squared minus 7x plus 3, so that's a polynomial expression, is divided by x plus 3, so that's a divisor, the remainder is negative 1. We need to find the value of k. So I always like to read the question the first time just to get an idea what it is about, and then read it a second time to better understand exactly what you're given and exactly what you have to find. And in the meantime, try to think of what we can use, what formulas, what theories, what strategies we can use to actually answer the question. So what we are given here is a polynomial expression, and we are dividing by this divisor, and we know the value of the remainder, and we are about to find the coefficient k, which is the coefficient in front of x squared. So this makes me think of the remainder theorem. If you remember, the remainder theorem states that if we're dividing a polynomial px by a binomial of the form x minus b, then the remainder would be equal to the value of the polynomial at b. In our case, the divisor is x plus 3, which tells us that we must have subtracted negative 3 from x, and that would give us the value of b. So b is negative 3. So the polynomial then, at negative 3, we have the same value as the remainder of this function, which is given to be negative 1. So what that means is that we are going to use this fact. So we have to find the value of the polynomial at negative 3 and make it equal to negative 1. So here is our polynomial expression. So negative 3 squared, cubed, plus k times negative 3 squared minus 7 times negative 3. So wherever you see x, you replace it by negative 3 plus 3 equals negative 1. So simplify. Negative 3 cubed is negative 27 plus 9k plus 21 plus 3 equals negative 1. Simplify the numerical terms. So we have negative 27 plus 24, negative 3. So take it to the other side, positive 3. So 9k equals positive 2, which makes k equal to 2 over 9. Now, revisit all the options given. So we have negative 12, that's a no, 0, and it seems that 2 over 9 is one of the options here. So this is the one that you would circle. Question 2. A possible equation for the graph shown is, so we have 5 different options here. So let's visit the graph of this function. It seems that we have a polynomial function. And as you can see from the end behaviors, the ends of the graph are pointing down, which tells us that this must be an even degree polynomial function, and the leading coefficient must be negative. So that's number one thing that we note in here. And a is negative. So let's take a look at the roots of, or the x-intercepts of the function, because that's what makes the equation of the polynomial function here. So we have a root at negative 2, we have one root at 0, and then we have one root at positive 3. In order to create the factors, all we do is take the root to the other side of the equation. So that means that this polynomial must have a factor of x plus 2. And for x equals 0, it means that it has a factor of x. And for x equals 3, it means that it has a factor of x minus 3. Now, the next thing we want to look at is the type of the root. So this is a first order root because it crosses the x-axis. First order root again. And when a function or when the graph of a function makes a turn at the x-intercept, it tells us that the root must be second order. So if we were to write the equation of this polynomial, then we would say that one of the factors is x plus 2. First order, so power 1. We don't have to write the power 1, obviously. We have the factor x minus 3, and that would be power of 2 because second order. And then we have the factor x. Usually we write the polynomials, the factors that are in monomial form first. And this would be the value, the equation of the function. And wait a second, one last thing. We said that this would be opening down, which makes the coefficient a negative. So let's take a look at all the options. Here we have negative x, x plus 2, we had x plus 2, x minus 3 squared. It seems that option A fits the equation that we just found. However, you want to revisit every single option because sometimes they seem very similar, but they're different in the meantime. So the next option here is not possible, right? And this one also not possible because it's not a degree 4. This is an even degree or degree 4. And the next option in here, x minus 2, it looks like it is the same as this, but that has to be x plus 2. And then the last option in here doesn't work either. So option A is the answer. Question 3. The equation defined by a family of polynomial functions of degree 3 with zeros 5, negative 3, and negative 2, with a member of the family passing through negative and 24, so that's a point where the graph of the function will pass through, is one of the following. So I would start off by building the equation with the information that is given. So this is a degree 3, and we are given 3 x-intercepts or 3 zeros or 3 roots. So what that means is that each zero will make a factor of order 1, first order. So x minus 5 will be the first factor here. And the second one will derive from the second root, which is x minus negative 3 or x plus 3. And the last one is x minus negative 2. So the factors will be x minus 5. I'm going to write them down here. And then x plus 3. And then x plus 2. So these would be the 3 factors of this polynomial function. But remember that in this question, you are also given a point. So that will help us find the coefficient a. And the coordinates of this point, x equals negative 1 and y equals 24, will be substituted in the equation for respectively x and y, or x and f of x. So we'll write 24 equals a. X is negative 1, so negative 1 minus 5, negative 1 plus 3, and then negative 1 plus 2. So 24 equals a. We have negative 6 times positive 2 times positive 1. So 24 equals negative 12a, which means that a must be negative 2. So we have to revisit now all the equations and check and see where we have negative 2 times each of these factors. So I wouldn't even look at the ones where the coefficient is not negative 2. So I would focus only on the ones that have the coefficient a negative 2. So let's check and see if the factors match. So x minus 5, we have x minus 5. X plus 3, we have x plus 3 and x plus 2. So perfect, so option C fits. And if it didn't, then you will have to revisit the rest of them, obviously. So question 4.